energy conservation. Means, and it's similar to momentum, the energy before has to equal the energy after. So let's say we're doing a coaster. It starts up on a hill, goes down, maybe there's another hill. Here is ground level. And then here's where the coaster's starting is up on the hill. So this is the before. Let's say we want to know how fast it's going once it gets to here. So that's the after. So we got the after here. We got the before here. Let's write our variables. Let's say initially it's going 10 meters per second. That's the initial. And let's say it wants to know the final. Let's say it starts at a height of 100 meters. And the other height is, so that's initial. The other height, let's say it's half that, 50 meters off the ground. Let's start there. We're going to ask ourselves, there's always 4 questions. There's multiple forms of energy. For us, we're going to be dealing with 4 types of energy, which is typically gravitational. So is it elevated? Kinetic, moving. So if it's moving, then we know we have kinetic energy. Is it pushed? Now, if it's pushed in the same direction that it's moving, then that's positive work. We add it. If it's being pushed in the opposite direction of its motion, then that's negative work. It's losing energy, so we would subtract it. And then the other type of energy is springs. So if it mentions anything about a spring, then we'd add in the spring energy. So for this problem, we'll ask ourselves the 4 questions. You ask the same 4 questions for before and after. Before, were we elevated? Yes. Then we will write down gravitational potential. Were we moving before? Yes. We said we were going to be moving at 10 meters per second. So we would add in kinetic energy. Were we pushed? We were not pushed. It would have to clearly say you were pushed for this amount of distance, either in the direction of the push or against the direction of the push. And it mentions nothing about that. So there is no work in springs. There's definitely no mention of a spring. So that is the energy beforehand. And then that's going to equal the energy after. We're going to ask ourselves the same 4 questions. Are we elevated at the end of this where it wants us to know how fast we're going? Yes. So we're going to write down UG. Are we moving at the end? Yeah, it's asking how fast are we moving at the end. So we'll plus K. Again, was it pushed? Doesn't mention it. So we don't have that. Was there a spring involved? No, so we don't have that. So now all we got to do is plug in our variables. We need to make a note that these are all initial. These are all final. They're not equal. They're not going to cancel out. So our next step is, well, what is UG? We can look this up. It's a simple equation. You don't have to memorize these. It's m mass times gravity times the initial height plus the kinetic energy, which is 1/2 mv squared. And again, that's the initial velocity. And that's going to equal mass times gravity times height final plus 1/2 mvf squared. Now what's nice is they didn't give us the mass, but we don't need it. There's a mass in every single one of these equations. So we can cancel that. We can only do that because it's in every single one. If it's not in every single one, you can't cancel it. Our next step is to plug in our numbers. The G is always 9.8. It's positive. Energy is always going to be positive. The only time we have to worry about a negative is if we're pushed opposite the direction. If it's taking energy, if the push is taking energy away from us, then we subtract it. So you get 9.8 times 100 plus 1/2 times 10 squared equals 9.8 again times, this time we're 50 meters above ground, plus, I'm going to squeeze this in, 1/2 VF squared, which is what we're looking for. So from here, we're going to do a little algebra. 9.8 times 100 is 9,800. No, 980. Sorry. Oop, erase that 0. Plus 10 squared is 100. Half of that is 50. Equals 9.8 times 50 is 490 plus 1/2 VF squared. All right, so we're going to add the 980 plus the 50 and then subtract 490 from both sides. So let's just write that out. So we're going to do 980 plus 50 minus the 490 from the other side. That's going to give us 540 equals 1/2 VF squared. Now you can either multiply both sides by 2 or divide both sides by 1/2. It doesn't matter. It's going to cancel out on this side. You just got to be careful. You're dividing by 1/2. So this is really 540 times 2, which is going to give us 1080. So we're going to have 1080 equals VF squared. So to get our final answer, we just need to square root that. This gives us, final velocity of 33 meters per second. Last thing here, you can have any forms of energy. Let's say you were elevated but not moving at the beginning. You would just have UG at the beginning equals, let's say you were elevated and moving at the end, then you'd have UGF plus KF. Let's say you weren't elevated at the end, then you would just have U equals K. Let's say you got a push at the beginning and you were on a hill, then you'd have W plus UGI equals, and let's say you're at the bottom of the hill, you're no longer elevated, you're just moving, then you would just write equals KF. Now let's say a spring shot you while you're on a hill. So you'd have UG plus US. And then let's say you want to know how fast you are going at the end while the brakes are applied. That would the brakes are going to apply friction, which is your force, which is going to be a push in the opposite direction of your motion. So we're going to subtract the work. So there are multiple possibilities with these. You just have to ask yourself the 4 questions each time you do one.